All right, so I'm going to give you a short video to review your balanced equations. You did very well in the balanced equations. There's a few that I'm just going to go over with you. The first one, I know it looks a little strange. Barium for oxide is usually BaO, but this happens to have a +4 charge because of the extra electrons that it can lose. So it has a +4 charge, and so it's combined with 2 oxygen. That doesn't really matter, but what we do need to do is put some coefficients in front of some of these formulas. Take a look at, there's 2 oxygen on this side, but there's 3 oxygen on this side. So we do have to do something with this formula, and we have 3, so I'm going to put a 2 in front of this barium oxide because that'll make it an even number. When I do that, I need to put a 2 in front of the barium in the reactant side just to make the barium equal. 2 barium reactants, 2 barium products. Let's see if the oxygen balanced out. 2 oxygen plus 2 oxygen is 4. 2 times 2 gives us 4 oxygen. And I'm just going to switch to a different color for my coefficients. That pink looks a little light. All right, taking a look at the next equation. The next equation, we have 1 lithium on each side, 3 hydrogens. So we have an odd number here and 2 hydrogens here. So we definitely need to take care of that. The oxygen's the same, but let's take care of the hydrogen. Let's put a 2 on the side where there's an odd number of hydrogens. So we have 2 plus 2, that gives us 4. So let's put a 2 in front of the water so that we also have 2 hydrogens in the reactant. So we have 4 hydrogens, 4 hydrogens. Now we have 2 oxygen, 2 times 1 on the reactant side, 2 times 1 on the product side. Lithium, lithium is not balanced, so let's put a 2 in front of the lithium. That takes care of letter B. Letter C, right here, hydrogen peroxide plus water. All right, let's take a look at this. What do we have over here? We have an odd number of oxygen. So let's take care of that. Put a 2 in front of the water. 2 oxygen, 2 times 1 plus 2 gives us 4 oxygen. Now we need a coefficient of 2 in front of the water on the reactant side. 2 times 2 gives us 4. So we have 4 oxygen, 2 plus 2. We have 4 hydrogen. 2 times 2 gives us 4. And 2 times 2 gives us 4 hydrogen. And let's see. Let me start listing them on the side for you. Take a look at this one. Hydrogen plus sodium gives us sodium hydride. We have 2 hydrogen in the reactant, so we need 2 hydrogen products. So we're going to have 2 hydrogen. Now we have 2 sodium products. We need 2 sodium reactants. So we have 2 sodium and 2 sodium, 2 on each side there. Letter E, let me take a look at my notes here. Okay, letter E, we have, I'm just going to zero right in on our odd number and see if we need to work with that. 4 oxygen plus 4 oxygen, 2 oxygen plus 2 oxygen gives us 4. 1 more gives us 5 products, and we have 4 on this side. So let's start with the water and make this an even number of oxygen, and we'll see what that does. 2 times this is 2 plus 2 plus 2 gives us 6. Okay, but we have a slight dilemma here. The only thing I can do to my sulfuric acid is put a 2 in front of that, and that gives me 8. So how are we going to fix this? Well, what I'm going to do is take a look at, maybe I need to work with something else. What about the sulfur? There's 2 sulfur and hydrosulfuric in front of the hydrosulfuric acid. So let's put a 2 in front of the sulfurous oxide. All right. So now we have 2 sulfur, all right, on both sides. Now we have 8 oxygen, 2 on this side. So we have 2 plus 4 plus 2. Look at that. We have 8 oxygen on both sides. Hydrogen, 2 times 2 is 4. 2 times 2 is 4. So we have 4 hydrogen on both sides. Letter F. All right, take a look at the hydrogen and the nitrogen on this side. We have 3 hydrogen, that's an odd number, 2 nitrogen, that's an odd number, but on the other side we have an even number of nitrogen and hydrogen. So let's double what we have on this side, all right, and then let's just make everything on the reactant side equal. 2 nitrogen, well that's already equal, we're good there. 2 times 3 gives us 6 hydrogen, so let's put a 3 coefficient on the reactant side, so I have a 3 times 2. So now our hydrogen is 6 on both sides, and our nitrogen has 2 on both sides. Letter G is already balanced, so we don't need to do anything to that one. Take a look at this. It might be a little tricky. Let's just count them. Nitrogen, there's 1 nitrogen on each side. I think that's pretty easy. Take a look at the hydrogen. 3 hydrogen in ammonia and 1 hydrogen in hydrochloric acid. So that gives us 4 hydrogen. And then you can see on this side, the ammonium chloride has, in fact, 4 hydrogen. There's only 1 chlorine in the reactants and 1 chlorine in the product. All right, I'm just going to go ahead and end that.